Hello, KCD Munich. Super stoked to be here today and to speak about Ingress and the new star in the Kubernetes ecosystem, Gateway API. My name is Simon Pierce. I work for a company called Sys11 based in Berlin. We're a cloud service provider. We offer traditional OpenStack services, and we also build Kubernetes clusters on top of OpenStack, which might seem unusual to some people here. We've been doing this quite successfully since 2018 now. We run over 400 Kubernetes clusters, managed and unmanaged, for various customers. The majority of them are in Germany, Switzerland, or Austria. So if you have any questions towards Kubernetes and OpenStack, please feel free to talk to me later on. Okay, let's get going. So goodbye Ingress, hello Gateway API. Of course, this talk is BIOS. I've made certain assumptions and chosen certain software to show the demo later on. There's like multiple ways that you could solve these solutions. And of course, as always, there's like loads of software in the Kubernetes ecosystem, which will assist you with Ingress controllers and also Gateway API implementations. Okay, let's get started then. So as I said, my name is Simon. I've been working at Sys11 since 2013. My hobbies, anything Linux related, tinkering with Raspberry Pis, and if I've had enough of all the computer stuff, and I like to go out on my bike, gravel cycling, and cyclocross in the forests of Brandenburg. So to the agenda today, I would like to briefly talk about application routing, basically how that works, why do I need it? The majority of you probably already know that. The Ingress API. So the Ingress API is still the stable API, which the majority of people are probably still using. And also, as I said, this talk is about Gateway API, of course, so I'm going to show you a lot of things about Gateway API. Gateway API has not got the same maturity as the Ingress API implementation. I think this would change very rapidly, but there's still a few rough edges, which I will also talk about. A bit about migrating Ingress rules, what options are available there, what can you actually do. A bit about Cilium, because Cilium was my CNI of choice, and I'll talk about that as well and tell you why I'm using Cilium and what maybe some of the advantages are of using Cilium versus other CNIs. And a bit about Gateway API and Envoy issues that I encountered during setting up this demo. As I said, not everything is GA or production ready, I would say. It depends probably who you ask, but I would definitely say I would not use all of this technology in production yet. And at the end, I'll show you a short demo about how Gateway API works. Okay, so application routing or application routing. So typically, you're trying to expose an application to the outside world. This is one of the things about Kubernetes, which definitely makes Kubernetes in some form also secure, because deploying a pod into a Kubernetes cluster does not make it available for the outside world. This is typically what you want to do later on. You want some domain, some load balancer, no pod service, however you want to do it. You want some form of exposure to the outside world. You typically want to support multiple protocols. So these would typically be TCP, sometimes maybe UDP, probably a bit seldom. And you also want to ensure that you can do cross-namespace routing. So your application and your Ingress controller could be in different namespaces. They probably should be in different namespaces as well, so that you can secure things, and maybe you also have different teams that may deploy these services within your cluster. I'll talk about that as well. And you definitely want some form of TLS, SSL certificate support. Mutual TLS maybe, if you're looking at things like service message. This could also be of interest to you. And what not very many people do, but I find is a critical point in administrating a Kubernetes cluster in production in a safe manner, is network policies. But as I say, I don't think many people actually use these. Ingress API. So the Ingress API was the first Kubernetes API for application routing. It's been there basically since the beginning of Kubernetes. It's a stable API. It's got multiple adoptions, so you can find like lots of companies that offer commercial and non-commercial versions of Ingress controller, for instance, Nginx, Traffic, and there's a lot more available. There's limited protocol support. This is one of the issues with Ingress controllers in general. You can use them for HTTP traffic only. So what are you going to do if you've got some other application that you would like to? You definitely can't use an Ingress controller. And it's got quite a hacky configuration via annotations. Depending, of course, who you ask and how many annotations you need, you could end up looking something like this or even worse. This is something I took off one of the services, which you can probably already identify, of a Keycloak service, and we needed to add multiple server snippets. It becomes ugly after a while, and I've seen things which are even worse. So you just keep on stacking up on configuration settings, and it's not really helpful. And it also allows, or typically could allow, application developers to overwrite certain things in the Ingress controller as well. So Gateway API, as I said earlier, this is the new star in the Kubernetes ecosystem. We've got north-south with Ingress. We've got east-west mesh, which is very new, and they can all share the same configuration. So you do not need to install multiple software components within your cluster, not necessary anyway, to solve this problem. It's Kubernetes SIG project. Any of you that are not familiar with Kubernetes SIG project, these are these special interest groups. So typically, if something is taken up by a Kubernetes SIG project, then it's got quite a good likelihood of becoming GA and actually landing in the Kubernetes master branch and being released, or in one of the other subsets of the project. It offers layer 4 and layer 7 routing. It's also got its own Ingress implementation, so you can still use Ingress with Gateway API. That's also possible. It has load balancing and a service mesh API. And one of the most important things, it's also role-orientated. The Ingress implementation was kind of partly role-orientated. You could also have separations of concern, but it was a lot more difficult to actually get this done. And the Gateway AI implementation has done this in a lot more detailed manner. So you typically start off with a gateway class, which would define a set of gateways. So this is the top-level resource. This could be typically deployed by someone, maybe a platform engineer. So in case of Cilium, I'll go into this later on, this can be part of the CNI software itself. Then you would have a class which would define a subset of gateways. Then underneath this, you have a gateway, which could typically be connected to something like a ELB, so an elastic load balancer, some form of cloud load balancer, which would then give you a public IP address and the connection to your cluster. So you could have, of course, multiple of these as well. These can be shared between developers and between different applications if you want to. Underneath this, you have routes which actually map traffic to services, because in Kubernetes, we always map something to a service, not to a pod. Pod IPs can change. Services are an implementation which they have the same IP. They can be looked up via core DNS within the cluster, and you can use them to route traffic to. And within Gateway API, there are different types of routes that you can use. So you've got HTTP routes, which can serve, as it says, HTTP traffic, but also it can also offload TLS traffic. This is also possible. You have TCP routes, which solves one of the limitations within the Ingress API specification. So you can route other TCP applications that you may have. So you could run different things which are basically not HTTP based. You have UDP routes, which you can also use. I don't think many people will need this, but it's nice to have if you do ever need it for any application that you're running. And also something which is new is gRPC, which you can use for any type of gRCP application. For instance, Argo would be an example. And now to the personas and roles within the Gateway API. The majority of you might not have all these personas, which are in this. See if I can do this. So at the top, we start off with the infrastructure provider. This is typically would be someone that would set up the cluster for you. So this would be someone that, in Cilium's case, would install the gateway, the CNI, sorry, and also the first gateway class. Under this, you could have a cluster operator. A cluster operator will provide you with a public IP address to be able to route your traffic to and also point your DNS entry to. As I said, you could have like a shared gateway, which you can use. You can also have one gateway per application if you need this, or you could even separate this maybe in internal and external services. So, for instance, you probably don't want to expose your Grafana or your Prometheus to the outside world. You probably only want to expose this to your company and to the employees via a VPN or something else. Then you have the application developers, and they can create TLS routes, HTTP routes, and point them to an individual service. So as I said, it's not always necessary to have all these personas, but it's nice that you can do if you want to. So quickly about migrating Ingress rules. So we've basically got a software called Ingress to Gateway, which you can use. You can find it on GitHub. This will allow you to migrate existing Ingress rules to Gateway API resources. In general, I would say you probably only need this if you're actually planning on migrating hundreds of rules. If you just got like a few Ingress rules, you can probably rewrite them fairly simple. And you probably learn something on the way as well. But it's interesting to give it a try and to see what comes out at the end. And it's also a Kubernetes SIG project. And it has support for multiple Ingress providers, so you can say which Ingress provider you're using, and it should be able to migrate it. I gave it a quick try during the demo, and it worked without a problem, and was able to migrate all of my Ingress rules that I had in the cluster. Okay, next up is Cilium CNI. As I said, I mentioned this earlier, this is only one possible way to solve this problem. And I'll tell you why I'm using this. So Cilium CNI, number one, gives you ePBF, which is the extended Berkeley packet filter, which allows you basically to inject microcode into a running kernel and do loads of things with it. It gives you native routing, which basically, instead of using something like IP encapsulation, you can basically route packets within a network with native routing. So typically, when we switch from IP encapsulation to native routing, the cluster's got about between 10 and 15% faster network throughput. So this definitely can be a game changer depending on your current CNI setup. You get BGP, and you also get layer 2 routing as well, if you need this. And you get Ingress, Gateway API, Service Mesh, which they've all solved with the Envoy proxy. And there's no extra controller needed. So after you've installed the CNI, you can basically use all these features if you've configured it correctly without having to install any additional controller or anything, which I think is a really nice way of solving this problem. You can get WireGuard or also IPsec, network encryption, within your Kubernetes cluster if you want. So it would like encrypt the node-to-node communication if you need this. The WireGuard one is really easy to set up and basically just works. And you also get something really nice, observability with Hubble. Hubble is a really nice piece of software, and it allows you to basically look into all this pod-to-pod traffic, which is kind of difficult if you're trying to debug it. It gets even worse if you're using IP encapsulation, because then you like change packets, you need to look into this bubble, what is going on. It can be super complex in a microservice world to debug why things aren't working. And Hubble is definitely your friend. It will help you a lot, and it's super easy to use. And last but not least, you also get network policies if you want to use them. So these will help you to ensure that only certain pods can, for example, access your database service or something. You can basically stop this with network policies. You can ensure that these are enforced and that they work. Of course, you can also shoot yourself in the head with network policies, because it's very easy that you don't have any DNS resolution or things like this afterwards. So be careful what you're doing, especially if you're applying them to a live cluster. And yeah, last up, cluster mesh. So Cilium will also allow you to build 2 clusters in different cloud regions and connect these to each other with cluster mesh, which is also a really nice idea, and it's also really simple to set up as well. Okay, so gateway API envoy issues. I'm sure that some of these will be fixed in the near future, but these were like issues that I encountered during setting up this demo. So number 1, currently Envoy does not run on Raspberry Pi OS. Probably not a severe issue to the most people, but something I encountered because I was using a Raspberry Pi to install it. There's like a memory allocation error, so you can't run Envoy at all on Raspberry Pi OS at the moment. You can solve this if you, number 1, recompile your kernel. I'm not sure how long this is going to take on a Raspberry, probably 10 hours or something. So I'm not sure if that's a good solution. And to do this, you need to change the PG tables level. Another option would be to recompile Envoy. Also, I'm not sure if people really want to do this, but you could, theoretically. Or my preferred, so you need to define tmalloc gperf tools to do this. My solution would be either use Debian or you use Ubuntu Lite or something like this on your Raspberry if you really want to use Envoy. So this is the current situation to Envoy. And another severe issue which I ran in with Envoy was when the Envoy pods, so I was running Envoy with a separate daemon set, so you can have it like either, you can have it in your Cilium pod as a binary, or you can have it as a separate daemon set. I was running it as a separate daemon set, and when the Envoy pod is on the same compute node as your application, you get a 503. So this is definitely something that needs to be fixed ASP, I would say. There's also multiple issues about this on GitHub, so I'm sure it's only a matter of time. I actually solved this using taints and tolerations, which can be a solution, but of course that also means that you can't deploy your application on all nodes in the cluster, because otherwise it won't work. So I basically separated the Envoy pods from the application pods. That's basically how I solved it in this demo cluster. And the last thing I found was that gRPC routes were broken with TLS. Probably not a big issue for the most people, but it was definitely also something that caused me a few problems. Okay, so demo prerequisites. What did I actually install in my demo cluster to get it up and running? Of course, I installed the Cilium Helm chart. To get this running, you need to use the kubeproxy replacement, which I would recommend anyway, because it's definitely a good idea, and it would give you, typically give you a better throughput, definitely than the IP tables one did. Set gateway API enabled, of course. The layer 7 functionality is enabled anyway in the Helm chart, so you don't need to do this. Then you manually still need to install the gateway API CRDs. This will change in the near future, but at the moment you still need to do this. And you can optionally, I would recommend it, but you don't typically need to. For my demo setup, I'm using Cert Manager and also external DNS. So Cert Manager basically issues my certificates, and external DNS ensures that the IP, which I'll show you in a minute, is going in my shared gateway, gets added to the DNS once I add my route with the domain name in it. All recent versions of external DNS support Gateway API as well, because you need it needs to have the correct listener configured. So ensure that you have a look at the Helm chart if you want to do this. Okay, let's do the demo then. So I'll quickly switch my screen. And make it a bit bigger for you guys. OK, so what I'm going to do first is I'm going to start off with installing the gateway API. The shared gateway first, because this takes a while. So I'll do this first, and then I'll show you the actual YAML afterwards. OK, so number one, we should have a gateway class now, which we had after I installed the CNI. So this is what I said to you earlier. Once you've got the CNI, in my case, in place, and you've installed everything correctly, you get the gateway API controller. So this is basically waiting for gateways. And and the gateway looks like this that we need. Is this big enough? Can anyone see in the back? Oh, OK. So basically, you have the namespace at the top, which we're installing it in, and then underneath you have the kind gateway, which is a shared gateway, I called it in this demo. You've got the annotation for the cluster issuer, so it can also issue a certificate. It's got the gateway class, which we're using, which I just showed, Cilium. And then you basically open up listeners. So I've got one listener for HTTP traffic, and it's allow routes from all namespaces. So you could limit this if you wanted to certain namespaces, or I think comma separated namespace if you need multiple. And I've also got an HTTPS route, which basically has a wildcard for metacube.org, which is a managed Kubernetes product. And this will then use this Let's Encrypt issuer to grab a certificate. And I'm making it super easy here. I'm just using a wildcard certificate. Then I only need one certificate for everything. And then you have the certificate reference underneath. Even if you're just using TLS traffic, so HTTPS, you probably still want an HTTP listener, so you can do the redirects if you want to do redirects. So let's see how far our gateway is. So if everything works, we should have a gateway here. And we've been issued a public IP address. This is done by our OpenStack cloud. So we have a cloud controller running also in the cluster, similar to AWS or to Azure if you're working there. And it basically grabs an external IP address once it starts, once it sees an external load balancer request. So if, maybe put a header in front. Yeah, so we're getting an answer. We can already see it's our envoy coming. As we're not sending any host header and we have no routes configured, it's not doing anything. So next up would be, let's install an application. So I have two different ones. So let's start off with the V1 version of my application, which should give me a new namespace and 2 pods. And I want to connect a route to these 2 pods so we can access them from the outside. So I'm going to create this, and then I'll show you the YAML afterwards. So let's start off with an HTTP route. And have a look at this HTTP route. HTTP. OK, so this is a simple HTTP route. It does HTTP only, nothing else. So it's basically got the namespace it's working in and a name. It's got my host name, so I'm using a subdomain, of course, of metacube.org. So we get the certificate, which we're not using here yet, but we'll extend this in the next example. Our section name is the route that I showed you in the gateway. So we're using the HTTP route. And the namespace of my gateway is shared gateway. That's where our gateway resides with the public IP address. And all the traffic comes routing through here. And it matches basically a simple path prefix and gives us a backend to use. So hopefully, if this has come up, then it should have added something to the DNS. Let's have a look. And we should have an HTTP route. And this should be metacube.org. Let's have a look, see if it works. And hopefully, if this works, we should get a 200 OK back from our envoy. So this route is working. We now have a working HTTP route. But who's going to want HTTP traffic only? This is basically, in today's world, this is basically a no-go. So the minimum that we're going to want, let's do an apply and add this on top of it, because we're going to use the same. The minimum we're going to want is a redirect. So let's add a redirect. I'll quickly show you how this looks. So you've seen this too. It's an HTTPS redirect. So the top is basically very similar to what we've just saw. The only difference is here now we have an additional filter underneath, which is going to do a redirect via 301, and it's going to go to the route here in the bottom. So if this basically works, then all of the HTTP traffic gets routed to this HTTP route and gets encrypted. So as you see, we're still using an HTTP route here. We're not using a TLS route. The main difference is the HTTP routes are offloaded by the controller, so the internal traffic within the Kubernetes cluster will still be encrypted. If you're using a TLS route, you need to ensure that your pods also have a certificate. Otherwise, it won't work. OK, so let's see if this works. And if it does, then we should be able to do a curl on our service. And let's do a redirect. And no, it doesn't. There's definitely a problem with the SSL looking at it. So it's definitely done a redirect, but for some reason, either certificate has not been issued. Let's have a look. That's interesting. So for some reason, it has not issued a certificate. So then we're going to have to continue without a certificate, because I don't think we have time to fix this now. That's a shame. During the preparation, this all worked. So it's doing our redirect to HTTPS. And if we have a quick look, we should actually see that this should now redirect, but it's probably using a self-signed certificate for some reason. So for some reason, the cert manager has not issued a certificate. Quickly start the browser and have a look. So hopefully if this, it says it's got no healthy upstream. That's interesting. Let's quickly. So the demo gods are not on my side today for some reason. Let's have a look. Yes, it should do. So let's have a quick look at the shared gateway. So it's the same IP address, which looks correct. So, but for some reason, it's not issued the correct certificate that I need. Let's have a look at the logs quickly and see if we can find out why. So for some reason it has not given me the secret and the certificate, which I actually, there's no secret here and there's no certificate. Okay, that's strange. So I don't think we're going to be able to solve this quickly. So the idea afterwards would have been to use the gateway API to do, after the HTTPS redirect, to do a split between two different pods. So I can quickly deploy this, and I can give you a rough idea what this would look like, but I'm afraid it won't work correctly without a certificate. So what I would do first is deploy the second version of my web app. So I have two different versions of the web app. And once this is done, the idea would have been that we should get a split between two services. So I'll quickly show you the services. Oops. And it's basically the same implementation that we saw earlier. The big difference is that you get a traffic splitting between service A and service B. So what it should normally do, it would give you the domain that we saw earlier, and it would basically load balance between the two services, service 1, which was the first application I deployed, and service 2, which is the second. So basically it builds up on this example. So let's have a quick look, see if it's changed anything. I would think no. No, for some reason, it's not wanting to talk TLS with us. So I'm sorry, I won't be able to finish showing you this. But one last thing I can actually show you is maybe how this would work with Hubble. So the last thing I wanted to show you was basically I was do a port forward to the Hubble running in the cluster to show you how the actual networking would actually work and how you can actually make this visible. So let's have a look if we can find this. Sorry. I should have this. Oops. No, that's the wrong one. Okay, let's observe this. So you can use Hubble basically also on the command line, also or via the UI, and you can basically visualize the traffic. So if we do a curl to our service, we should be able to see. Okay, this isn't working either. This is strange. Normally, you should be able to see the traffic going into the namespace of the web app. Yeah, I'm sorry about this, that I couldn't get the rest of my demo to work. But you can definitely try it at home as well if you want to, which should work. During testing yesterday, this all worked. I have put all this together for you guys on GitHub with a few examples, so you can check it out. So the whole idea behind this should be build up a cluster, any form of cluster, it can be kind or anything else, deploy the Cilium CNI and the gateway API on top of this, and then you should be able to get a cluster up and running with Gateway API. Thank you very much for listening. Does anyone have any questions?
Thank you for the presentation. I just have one quick question. The traffic splitting that you do, does it also support failure domain? Does it also support failure domains?
Well, it supports any type of failure that results from your health checks, but otherwise it would just like route the traffic to the endpoint, and you can then set how much percentage of the traffic do you want to go to a certain endpoint.
Okay. So failure domains is across the availability zones in any.
You couldn't do this with one cluster, but you could do this with a multi-cluster. So that would be possible.
Okay. Okay. Thank you.
More questions?
Hey, Simon. One more question regarding the traffic split. Is there a possibility to make session persistence?
I think there is. I haven't tried this yet, but I believe there is. I think you can use cookies and things to do this.
Cool. Thank you.
Yeah.
Hi, you spoke about north-south traffic and east-west, but you only showed north-south, right?
Yes. So I didn't touch the mesh part at all. This is like still very new, but it can be used.
How this can be compared with Istio?
I would say also it greatly depends on the implementation. So I would think the Cilium implementation is a bit similar to the ambient of Istio. It also basically runs with Envoy. It's got its daemon set installed on every node and intercepts traffic, versus the sidecar approach, which could be tedious maintaining and having to run like hundreds of sidecars.
Okay, got it. Thank you.
Last one.
Thanks for the presentation. I was wondering, for migrating from Ingress to gateways, what are the considerations that you would recommend people to take into account?
So migrating, first set up definitely a development cluster, test everything, ensure that everything works the way you want it to do, and maybe wait a bit as well, because at the moment it's fairly early stages. And you could also, of course, give the Ingress to Gateway a try as well if you've got like a lot of rules that you want to migrate. Otherwise, I would probably just sit there and start rewriting the rules, because It's not super difficult, and you can learn a lot doing it as well. And maybe you want to change a few things as well while you're ongoing.
Thank you, Simon.
Thank
Again,
you.
a round of applause for him.